line up with my face. Get this going. All right. Got the chat going on the line. And okay, so everybody, thanks for your patience. Again, I hope that you will deem that it was worth it. If not, you can whack me over the head on your way out. Welcome everybody to Utah Stack JS, where we dive deep into the hard topics that other meetups don't want to talk about. I actually did have the benefit of giving a draft version of this presentation on Tuesday, which gave me some insight into restructuring some things. So we're going to talk about Passkeys. So welcome to Utah Stack JS. Thank you, Vivint, for sponsoring us, for giving us a place that we can meet and eat. And let's see. I will go ahead and get started because it's hard to introduce myself because I'm the person that's hosting and presenting. But yeah, quick round of applause for Vivint and also for me because I'm doing it. Okay, so with that, my presentation is Passkeys are kind of great. And this is what the passkey thing looks like. So if you've seen this before, then you are familiar with passkeys. On Windows, it looks a little different. I'm going to show that later. And I'm AJ. Most of you here know me. For those of you online that don't know me, there's some contact information for me. _ beyond code is my respectable tweets. I stream sometimes on Twitch as CoolAge86. And the root company is where some of my good code is on GitHub. I'm a deep learner, I'm a dangerous wrong thinker, and I'm a gun for hire. So if you are interested in what you see here tonight, I do some Go, some Node, I'm dabbling in Zig, I'm really liking it. Done just a few small projects in it. Stuff that has to do with network stack, security, anything Unixy. I do all that stuff, so feel free to reach out. I'd love to help you and work with you. So,
what is POSIX specifically?
What?
What is POSIX specifically?
That's not this presentation, but it is the standard for Unixes.
Okay.
So Bash.
As a web developer, I don't know what that is.
Okay.
Bash and Shell are built on POSIX or something like that ish.
Yeah, I don't want to go. I'm gonna try to limit the rabbit holes because this is a lot of material. Not any shade on you. I get stuck in the rabbit holes, so I'm trying to force myself not to do that, and I already am. Anyway, so we're going to do this in 2 acts. Act 1 is the happy path, and Act 2 is a bunch of mumble jumble that's out of order, but we'll go through some of it as the not happy path. Act 1 is the happy path. Okay, so happy path, we get this kind of thing. And the happy path is brought to you in part by PaperOS and Kyle Simpson, because PaperOS is who allowed me to be able to work on this to figure out all this stuff. And Kyle Simpson was able to provide some very valuable insight. So anyway, what are passkeys? Passkeys are the subset of WebAuthn that's implemented and that works. So it's kind of a rebrand for WebAuthn. And the way to think about passkeys is that it's the password manager reloaded. So characteristically, it's like a password. It's just higher entropy and it's push button. The user doesn't have to remember it specifically. We'll get into a little bit more of that later. The platform support is baseline. Baseline, I put a little TM there, it's not TM, but that's the term that the evergreen browsers use. It's what's used on caniuse.com, MDN, and other resources to let you know that the support is widely supported. Not only is it baseline, it's been baseline for more than 18 months. I don't remember the exact timeline on it, but if you were trying to do passkeys, I'd say about 2 years ago, WebAuthn, let's call it WebAuthn. If you were trying to do WebAuthn 2 years ago, your experience would be very varied, and that includes some sadness. Nowadays, passkeys have baseline support across all the evergreen browsers, and even if you're dealing with Android browser, UC browser, or WebViews, which and then Chrome on Android. All of those, they all work. There are some caveats there. We'll go over that too. And then there is universal OS and cloud support. So whether it's Chrome OS, Google Sync, Microsoft Thingy, Apple iCloud, Mac OS, all of that stuff, it all supports Passkeys. So it's a really good time to be considering Passkeys for your development. And the product support is really great too. So there's the Android thingy. They don't have a branded term for it. Face ID, Touch ID, YubiKey, Windows Hello, all of those things, they're all working in unison and together. Now you might think, well, not all of my customers have those technologies, and that's okay. Because if it's an older version of Windows, if it's an older computer, if it's an older phone, then if Passkeys are supported, it will fall back to something like this. So this is what Windows looks like. On Mac, it literally just presents an OK button. That you can either click the X in the corner or you can click the OK button. So it is true progressive enhancement. So Passkeys, again, they are like a password. So we don't say, oh, passwords are insecure. We say, well, a short password that has very little entropy is insecure. Likewise, when you're looking at, all I have to do is enter in my Windows PIN. I don't have to do any bio-identification. That's fine. Because the base level of Passkeys is just a higher entropy, more consistent password with a better user experience. It's not to be ultra, in an enterprise scenario, you can set the settings you want. Let's say that. But what we're really working towards is having a better password manager, but it's a passkey manager, and it's being handled by these platforms, operating systems, browsers, etc. And it's being progressively enhanced so that if the browser, or the hardware rather, doesn't have the latest up-to-date features, it's still going to be a great experience for your users. So let's go ahead and take a demo of this. If you would like, passkeys.js.org. I think it'd be great if everybody were able to go there, because it would be great to know that it works for everybody equally well. Oops, that's not what I wanted. Okay. Okay, here we are. So this is a little demo with all the cruft taken out. If you look at the WebAuthn options, you'll find that there are tons of them. Most of them are for supporting older use cases that existed in the past, or very, very specific enterprise use cases that were part of the agreements and the consortium to get the spec out the door. So that's kind of why I make the distinction with Passkeys. Passkeys, like I said, it's just like a password. So when we do this, just click in the email or username field. There is a special attribute on the input called WebAuthn that causes this to appear. Now this, use a passkey, is actually not that useful, but what is useful is that when there's already a passkey there, it gives the person the experience of being able to click on it directly. So I'm going to go ahead and type in AJ at the root company, if I could type on a QWERTY keyboard.com. And the first thing that I need to do is register an account. Now what you typically would do, and which I wish I'd updated this demo for, what you typically would do is you'd have a continue button, and some of you are already familiar with this on your site. So you have a continue button, because what are you going to do? You're going to go check the email address, and you're going to see, is two-factor enabled? Does this person have passwords enabled or disabled? Am I expecting a passkey? So you have some of that information that you're doing already as part of your login. And so typically you're going to have a continue button, and you're going to go and fetch to see if there are credential IDs. We'll get into that in a minute. They're strings. They're just strings, random strings that are produced by, we'll get into that in a minute. But, so that we wouldn't present the user with both of these options simultaneously. We would present them with one or the other. But for the purposes of this demo, I'll go ahead and click Register New Account. And we can see that the fingerprint mabob comes up. So go ahead and fingerprint that for me if you don't mind. Borrowing somebody else's computer so I can both record and present at the same time. All right. And then it pops up with some debug information. And now I'm going to go ahead and refresh the page. And now it looks like there you have some sort of browser plugin installed that's competing with this, maybe LastPass or something like that.
It's Apple iCloud and Chrome competing.
Okay. I have not experienced that aspect before, but that's not
If it's,
normal.
so like Bitwarden does that for me.
Okay.
But I can just say, don't use Bitwarden. Like, it has an option to use a device key or something.
Yeah, so I just want to be clear that that double pop-up is coming from some sort of browser plugin. That's not the default behavior of the browser or the operating system. So I'm going to go ahead and just click here and then go ahead and touch. And then it comes back and there's going to be some debug data there. Boop, there we are. Okay. So what you saw was register, and then you saw autofill. And then the last one is going to be click. So these are the three modes of passkeys. Register or replace a passkey, use autofill to get the passkey, or get the passkey if we know that there's a passkey. So I'm going to go ahead and click sign in with passkey, and you can go ahead and do that again. And then I want to show one more flow that happens here. Depending on which operating system you're on, you do get different flows, and depending on what some of the options previously were. But I'm going to go ahead and do AJ at the root company. And it doesn't have to be an email address. It could be an arbitrary string, username, whatever. This doesn't actually have a server at this point. This is just to demonstrate what the flow would look like. But you can register more than one passkey. So I can register a passkey with iCloud, but if I click cancel on that, then I get the option to select from the browser, what would you like to do? And so I can select my Chrome profile and then continue. And then I get a slightly different prompt. This prompt comes from the browser rather than the operating system. If you place your finger again. There we go, and that's some debug information. And then if we look in the credentials tab here, this is a bunch of debug information that's just being saved locally. And you can see that there are two passkey credentials. Both of them have an email address and a bunch of other stuff. If I was doing this on another computer, there would be different information because there's some information that only happens on register. So this is showing all of the information. But that is essentially, from the UI perspective, that's the passkey process. From the server perspective, which we'll go into in just a minute, basically what it did was it created a credential that has high entropy, so essentially a really, really, really long password. And then it used that, it hashed that really, really, really long password with a salt, and then it returns it to the server. That's essentially what's happening here. So let me go back to the presentation. All right, and we'll go on. So these are the three modes that we just saw. Mode 1 is register, which is also called in the documentation. It's called a few different things in the documentation. It's called register or WebAuthn.create. And you can see here it's navigator.credentials.create and then registration options. And there's also this autofill controller abort, which before you do any action that you can explicitly await, basically a button click action using passkeys, you need to abort the autofill action. There can only be one passkey action at a time, and the autofill is one of those three modes. So there's register, there's login. Login has login options, and that's navigator.credentials.get, so .create or .get. This is also WebAuthn.get. And then likewise, for either of these things that you would be using a click or some sort of dare I say, it's asynchronous because it's JavaScript, but it's sequential. It's part of a process. Like they're going to click, you're going to respond to the click immediately. It's certain when the click is being responded to. The autofill is slightly different. So the way the autofill works, we'll show how this is set up later, but it's almost the same as the login options. But the autofill options has one key difference, which is there's a property called mediation, which is set to conditional. Conditional means autofill, and we'll go back into that again later. And we have to have an abort controller, just like we would with a fetch request. And the reason for that is that if we have the autofill enabled, and then we also, through whatever means, determine that we're going to push the user through the passkey flow, and they're going to click a button, what will happen is it will just throw an error. So we need to use the abort controller so that we can just cancel the autofill passkey operation so that we can do any of the other operations. So those are the three modes right there. And then you'll notice here, instead of doing these two, we can do let whatever equals await because it's in direct response to a click. On the autofill, I'm just voiding that out and then I'm providing an event handler. So if the autofill event happens, the event handler will get the same type of object that this would have gotten, but it will be through the event. Also, I did name this wrong. That should be assertion, not attestation. I get those mixed up
I have
sometimes.
a question.
Yes.
Like on the login one,
Oops.
where are you getting the autofill control?
So-
abort controller from?
So I try, it's kind of, there's interdependency here, right? So when you create an autofill passkey mode, that's when you create the controller. But the first thing that you would do as part of a user process is register a user. So I put these in list of 1, 2, 3. You're going to register a user, then you're going to log in the user, or you're going to do the autofill. So that's the logical process. But the code process, creating the abort controller for the autofill, will normally come first because you're normally going to have the autofill enabled until the user clicks the button, at which time you'll abort the autofill and then use the modality for the register or the login. Okay. So what this process looks like for registration is you're generating a challenge, you're getting credential IDs by email address or username. You're going to register the credential. That's so that the world icons are for what happens on the server side. On the server side, I generate a challenge. It's just a random salt that's going to be on the server. I need to get the credential IDs from the server. That's any information about this user's login process that's been stored previously. Then on the client side, I'm going to register the credential. That's what the customer is going to do. They're going to create the credential. And then on the server side, we're going to store that credential. And that's pretty much it. So there's not too much complexity here. And then we have an assertion phase. And so registration is you're creating a new passkey, registering a new passkey for the user. The assertion phase is that you're using an existing passkey for authentication. So essentially, again, passkey manager, password manager. Same thing, slightly different technology. So the assertion is just asserting that the challenge was valid. The challenge that gets signed by the server is valid. So similar process. First two things: we're going to generate a challenge. We're going to get credential IDs, and the credential IDs are so that we can determine what process we should try to put the user through. Because if we see they already have passkeys, we probably want to make sure that autofill is enabled, because they're probably going to click on it if that's what they want to do. But if they're logging in, maybe somebody else is using their computer, they're logging with username and password, we don't necessarily want to preclude them from being able to use that, but it gives us a hint. And it also has another very important function we'll get to in a second. So then the step that actually happens in the browser is that we're going to authenticate the credential. We already showed the code for that, the WebAuthn.get. Then on the server, we're going to send that. It's called assertion. We're going to send it to the server, which the assertion functions as the password. It's the sign, it's the signature, and some related data. We're gonna verify that message and signature on the server side, and then we may optionally update a counter. So some authenticators have counters, and there's a lot of terminology we're going to throw out, and then we'll get to as we go there. So the question that I'd like to be able to answer favorably for everyone in the room is, can you use passkeys without a library? You know, we take a look at the basic overview of the steps. Is this something that you, with your expertise, can handle and be able to work through in a reasonable amount of time, reasonably secure, and have a good experience? No. Well, maybe. So my goal with this presentation is to help you get closer to the metal, because I believe that you're better off learning than offloading a lot of this stuff. My philosophy flat is better than nested. A little copying is better than a little dependency. Favor reading code over writing code. If we can keep our code simpler, if we don't have to involve so many services, we're going to have something better for ourselves and better that we can hand off to other people in our company or other open source contributors, etc. The simpler we can keep things, the fewer abstractions, the better off we are. But sometimes we can't go all the way to the metal. We need to use abstractions to help us avoid confusion or intense tedium. And with Passkeys, there is some assembly required and nuance. There are things that are not intuitive that once you know, make it really easy. And that's what I'm hoping with this presentation. But the tedium, you still, if you don't have a library, you're going to end up creating a library. I don't believe you need a framework for this. The people that are selling SaaS products and frameworks, no. What I will be providing as the library for this that already kind of exists as part of the demo. If you take a look at that file, you could copy and paste out of it and get most of what you need. There are things that I've learned in the last few weeks of implementing this twice now that I believe I can simplify a little bit. But there is some assembly and some nuance. So let's talk about the auth vocabulary real quick, because there's words, and words can be scary when we don't know them. It's hard to listen to a sentence and hear 2 or 3 words you're not familiar with. That's already happened, I'm sure, during this presentation. So I want to get some of the vocabulary out of the way so that we can be comfortable and feel good about moving forward. So there's a new term here that you probably haven't heard before, which is auth-C. So we had auth-in, which is authentication, who has access, authorization, auth-Z, what can be accessed, and then auth-C is the authenticator, which is what mechanism is asserting the authentication. So then you've been using these for years, but now we need a specific term for them with the development of Passkeys and other things they interop with. So password is an authenticator. Well, password can be used to verify. Password itself is not the authenticator, but the function that authenticates the password is the authenticator. Magic links are authenticators. Passkeys are authenticators. One-time passwords are authenticators. OIDC, the sign in with Google, sign in with X, those are authenticators. So authenticator is a bit more abstract, but it is any of these things that accomplish that goal for us. Now, let's move on to the registration process and just look at the terms we need to know for this. And I'll try to disambiguate them the best I can. So registration is a multiplex term, meaning it could mean you're registering a user. You might register them with a passkey. In the context of passkeys, it means you register the passkey. Whether you are registering the user at the same time or not, you are registering a passkey. So it could be a new user or an existing user you're registering a passkey for. The challenge is a server-side nonce. Most of you have probably heard the term nonce before. A nonce is just, it means once, like only once. I don't exactly know why the N is there, but it's nonce means only once. It's a value that is used only once. So it's arbitrary single-use data such as a salt. What is a salt? Salt is just random data. And the purpose of a salt is to make a hash unpredictable. It's so that when you hash something, for example, when you go to then sign it, it's just unpredictable. If you were to sign 2 of the same thing, you would not see the same result. So the purpose of the challenge in the registration and in the other process, the assertion, is so that you know that it's only used once. So that's why it's generated server side, and that is why it's necessary so that we couldn't store a previous, like, I'll give you an example of something you could do with a password. You could store the password in local storage and then sign in without actually having the user type in the password. Passkeys, being an advanced password manager, allows you to specify some details of whether or not the user must have taken action, such as clicking the button or using the fingerprint in order to continue. So that's where it seems kind of silly, but to not get into the weeds, it's just to make sure that things are only used once and they weren't stored, there's no replay attack. Base 64, I think we all know what that is. base64. There's URL base64, which might be a new term, which means that respectively you replace plus, slash, or equals with minus, underbar, or nothing. You just delete it. So that's the conversion between your base64 to URL64. And a lot of this data is encoded URL64. So with that, the vocabulary out of the way. First of all, does anybody have any questions on this vocabulary? Okay, I probably need to look at it and use it anyway. Okay, so this is server side. So that's the globe. Globe means server side. So the challenge length can be up to 64 bytes. You should not make it longer than that because the challenge, in some cases, actually gets processed by a physical device. Now, for the most part, we're talking about Windows, Android, and Mac OS, but this device right here itself processes a challenge, and it also has NFC. It can do passkeys via NFC, so it's very low power and very low capacity in terms of what it can do. It has tables, basically has a little database inside, a CSV file that has a list of randomly generated IDs and some metadata, and it processes that. So the passkey specification, 32 to 64 bytes should be fine. I wouldn't recommend going higher than that. I'd actually use 32. I just show 64 in the example as that's probably the maximum that you could use. But 32 will be fine. In terms of security, they're equal. Then, and by equal, I mean infinity versus infinity times 2. They're roughly equal. So this is just creating, on the server side, I'm just creating an array of bytes, and then I'm filling it with random values. This would work in Node, Bun, Dino, whatever. Then I'm going to take those bytes and convert them to URL base64. And there is, this is something that you unfortunately don't get as part of JavaScript. Node does have a buffer object that you can use that will get you halfway there, and then you still have to do the URL conversion. I do provide some sample code that just does it for you one shot in JavaScript, because it's doable, it's just tedious. So, and then you'll have your database, and you'll have maybe some nonces for whatever use case. You don't need a special table for the challenge. You just need to be able to store this as an identifier, really, and then whatever metadata you want to associate with it. Maybe something about the login that's about to happen, the email address or something like that. So from there, we go into the credential IDs. Now, in reality, you'd probably want to get the challenge and the credential IDs at the same time, but for the purpose of making these slides simpler, I wanted to show them distinctly. So you'd have some sort of resource where you fetch credential IDs that have been saved previously. Again, these are just strings. They're strings that are returned as part of this process. But again, it's a little challenging because the one thing depends on the other, but I'm trying to show the process as how you would go through it. And one of the first things you do is check to see if it's done before. So we haven't actually seen the credential ID yet, but it's just a list of strings, and they are useful for the way that passkeys are implemented, which we'll see in just a second. So I would return those back to the application. Okay. So now there's a little bit more vocabulary that we need to go through again, because we're about to go onto the browser side, and we have to learn a little bit about what the browser is about to do. So we talked about authenticator. Specifically in the context of passkeys, the authenticator is the device or the platform. So the Android phone operating system or the Android phone browser, the iPhone operating system, the Mac OS operating system, or the Chrome browser, the Brave browser, the Firefox browser, etc. Platform, to be more specific, because I did just say platform, but what I meant by platform was actually slightly different there. Platform, well, I guess it's similar actually. Basically it refers to, is it something that can be removed, or is it something that is built into the device or installed on the device? So this would be considered cross-platform because I can remove it and put it in something else. iCloud sync would be considered cross-platform because you can be on one computer and then log into another computer. And something that is on the computer would be considered platform. Now, the way that they actually get registered, you don't need to know about this other than you need to know that it exists so that when you see it, you don't get too confused. It really doesn't matter because all this stuff gets virtualized anyway. iCloud, I believe, actually reports itself to be platform, even though it's cross-platform. You know, and it doesn't really matter unless you've got an enterprise use case where you need to make sure, no, it must be specifically one of these types of devices, not any generic device. Okay. Then we have credential. Credential in the broad sense refers to a public key. So it's a public-private key pair is how you do passkeys. And the private key you don't ever see. It's just baked in. It's part of the device or the operating system or the service, whatever. So you only get access to the public key. You only get access to it on registration. And then there is the credential ID. And the credential ID for the happy path that we're talking about, where we're not trying to support every device that's ever existed. We don't want to support devices that came out 3 or 5 years ago. We're not trying to support operating systems. Those we're just going to fail over to passwords. The credential ID is actually created by and stored on the device. So, or iCloud or whatever. And it is the credential ID is a pairwise ID, which means that I could actually have more than one credential for an account on this device or my Brave browser. I cannot have more than one credential on iCloud. If I were to create 2 credentials, I would inadvertently delete the previous one. That becomes important in just a moment. So pairwise just means that we're talking about it's between 2 things. It's the authenticator and it's the profiler of the account. Then we have relying party. This is just domain name. It's called relying party because it also applies to other devices. It's not just browsers. The WebAuthn spec is much broader than browsers. So it's called relying party. It just means the domain name. So nothing crazy there. And attestation is details about the device or service. So for example, this device actually does have, I believe, a public key that represents the manufacturer on it. You don't get that with iCloud, but you do get some amount of information about the device. So that's attestation. Okay, so with that all in mind, this is what setting up the request object for registering looks like. Relying party, we already talked about that, very simple. It's just the host name, and the host name is bound by cookie rules. So basically, if you have a app.example.com, www.example.com, other app.example.com, example.com, grandchild.app.example.com, whatever it is that you set the ID of the relying party to should be consistent, and it will obey cookie rules. So if you want to understand how those origin policies work, you can just look up how they work with cookies, and it's the same. So basically, if you have an app.example.com and a videos.example.com and a mail.example.com, you would want to set your ID to just example.com. Or you would want to have an sso.example.com through which you do an SSO process. Whoop, that's not what I wanted to do. Okay, so then here, display name, email, whatever. You get to decide how you're doing that with your user. Well, like I just showed, we showed the server side, but you'll have some sort of function in your app where you get the challenge and you get the IDs. Then here's something that's interesting, is that you can actually have a client-side secret. So you can store some arbitrary data that will be stored on the device that the server never knows, and that will always require physical or proximity interaction. So the user will have to click a button, touch a thing. It's guaranteed to never be given automatically. So you could use that for something like a cryptocurrency wallet or client-side encryption or some use case where you want some entropy or some data that's stored that you get back every single time. And then we would, of course, if we're going to do register, we would be aborting our autofill controller before we do the registration process. So when we put all that together, this is the literal object that we would need to have. Everything that is in strings here is stuff that you don't have to worry about changing. The variable stuff is what we did in the previous slide. This is all the stuff that you actually would be concerned about. All of this stuff here, stuff that you don't need to be concerned about, because essentially the options I've provided are the happy path options. They are the baseline options that if you want it to just work have a good time, those are the options that you provide. So just to go through those real quick, the registration options look similar to the assertion options. They're slightly different. There is a mediation. Don't need to worry about it. Signal, we've already talked about that. That's our autofill controller. In the registration, we probably don't actually need to provide the signal because we will probably not be in a scenario where we click the button over here. The modal comes up so the user can't interact with the page. So there's probably not a circumstance where you'd actually need to cancel something that was direct from a button click, but I had that in there. I might remove that in the next version because I don't think that there's a case where it actually is meaningful. Then we got the public key. We're basically specifying a query in this whole thing. It's a request. We're saying, what do we want to get from this thing? So we want a direct attestation. The reason we want that is if you ever needed to do any of the enterprisey stuff, it'd be good if you'd already had it from the beginning. Attestation is enterprisey stuff. You're probably not going to need it, but if you turns out you do need it down the road for compliance or for some reason, it's better off just to have it. So we set attestation to direct. Authenticator selection, resident key required, user verification preferred. Basically what this means is that it has to be a device that supports our baseline. If it doesn't support our baseline, then we just want it to bail. We don't want to try to use some type of previous version of FIDO key that doesn't support the current WebAuthn standards. If you got some enterprise use case, you can change that. Same thing with user verification. In all practical purposes, user verification is always ignored by all operating systems and all browsers. It will always prompt the user to click a button or to put their finger, and I don't think that will change because the powers that be won't be able to agree on what the alternative should be. So that one you don't have to worry about. A challenge, we already talked about that. Exclude credentials is actually really, really important. This is why we really need to get the credential IDs, because of iCloud and other authenticators that function like iCloud. If you accidentally present a flow to the user whereby you put them through the registration process, even though they have a passkey, that registration process will look pretty similar to the sign-in process, but it will delete their previous passkey, and then you might get stuck in limbo where your server thinks they have a passkey that you're trying to get them to use. You're not allowing them to register a passkey to replace it. Maybe you've got some local client-side state that's messed up by that as well. So exclude credentials is where we provide the credentials that we have, the credential IDs that we have, which says, hey, authenticator, if you recognize this credential ID, reject creating a new one. We don't want to have 5 different accounts on this for the same user. We don't want to have 5 different accounts in our browser for the same user. This and the browser will both allow an arbitrary number of accounts up to the limit. So iCloud only allows 1 account, and it could present just a weird situation if you accidentally overrode it. So that's just a precaution. If your app logic is perfect, you'd never have to worry about it. But also in other cases where a person was using one computer and then switches to using another computer, that having that knowledge of what their credential ID, if they're using iCloud, it's still going to work out anyway. But it's just nice to be able to have that use case covered. So that's why we have the exclude credentials, is we're saying whatever authenticator created this credential ID, don't let us make the mistake of overriding that or creating a duplicate. From there, pub key cred params, don't worry about it. You're just going to use public key -7. Why is it -7? Because the PDF was published that way and it says -7. There are some other algorithms that you could use. The only other one that you would use if you wanted to look into it would be -8, which is Edwards curve. All of the other ones you shouldn't use. They're either deprecated, not implemented, or they're just add complexity that doesn't increase security or give you any benefits unless you have some sort of, again, like contract with the military where the military says no, you have to use this particular thing, in which case you'll figure that out. All right.
Why is it negative?
Because they put it in the PDF.
It could just be
There's some are negative, some are positive. There does not appear to be any rhyme or reason to what the numbers are, but that one represents elliptic curve prime 256, which is the standard curve that all of your devices, SSH, et cetera, have been using for the last 10 years. So it's the most compatible.
I really dislike this one this much in proportion to the others that I dislike.
Yeah.
I think it actually goes in reverse. I think the closer they are to 0 on either side is better. I think I don't want to go in the weeds on that.
Maybe more like pH.
There's a lot of content here. So RP relying party, we already talked about that. One cool thing is that the reason we specified name in this is that in either the browser passkey manager or the operating system passkey manager, the name and domain that we specified, the domain is important for the protocol. The domain is actually part of the security policy. But the name is just so that it shows up in the passkey manager in the browser settings or in the operating system settings so that they can see what this was related to. So that's why name, the name of the relying party. And this was an object, if you remember, we just created it as an object right here, ID and name. So you put my brand in there, yeah, and that's what they will see in their whatever the authenticator is displaying to them. Timeout, you just want to have a timeout because you might not want, after 10 minutes, if they still haven't put their finger there, they're probably not going to put their finger there, so you just time out the operation. It doesn't really matter except for if you're looking at the older devices, then potentially somebody could come by and click OK when they're not them. Yeah. But yeah, so you just put a timeout if you want to be able to detect that the user has walked away from the computer or forgotten about it and have an error instead of just waiting forever. Especially if your server-side challenge has say your server-side challenge only is valid for 15 minutes, then you'd probably want to set the timeout to 15 minutes, etc. After that, we've got user, and this again is mostly information that's being used to display or for the cataloging on the authenticator. So whether it's iCloud or whether it's a key, name, this is where it gets a little tricky. Name is the unique field that the information will be registered to. Display name is what's going to show up as the friendly name that they see in the user interface. ID is not an ID. It is an optional field for arbitrary data. So it is not the field by which it's indexed. That would actually be name. So that could be an email address, a username, a phone number, whatever it is that you like. But ID is the client-side secret that you don't send to the server. So a little bit of confusion there. I'm not quite sure how it got to be named that, but Kyle Simpson was the one that kind of helped me figure out that this is the secret arbitrary data, and this is the data that will never be, it's spec'd to never be disclosed unless there's explicit user action. So again, that's what you would use if you wanted to have a cryptocurrency wallet or client-side encryption or anything of that nature. All right. So let's just take a step back for a second. So again, we were filling out some of the data that is variable. We put it into basically our template for what the fields that we have to have, and there are some fields that we must not have. This is correct. And then we get back to that simple call, right? So that's all that goes into that. There's a bit of tedium there. Now, board control, we talked about that. The create, we just did all of that, great. Oh no! What happens if I console.log the data that I just created? So this is another area of tedium. There's nothing that's challenging here. There's nothing that's crazy. Looking up the information does require going back and forth through documentation pages. But essentially what happened is there was supposed to be a toJSON method that has not been implemented. And so the object is opaque, meaning if you console.log it, it will be an empty object. You will not see any properties. You will not have any indication that this object is useful. You could rightfully think, oh, it failed and gave me an empty object. Not so. It's just that the properties of that object are considered sensitive, and so they will not be console.logged. You can only access them by looking up the documentation. So that's an area where, again, it's not like it's not challenging. There's not even anything here that you're going to learn about, computer security from this. It's just tedious. You just have to look up the documentation and map the object. And there was a toJSON function that was in the specification. It just never got implemented in any of the in the field browsers. Well, there might have been one, but you can't rely on it. It's not there. So you just create your own toJSON function, and this is what it looks like. Registration to JSON, and then you'll have the complementary assertion to JSON. So we have get authenticator data. That's a function that gets called, and then that ends up being data that you'll want to store server side. You personally probably won't need to use this, but again, it's just nice to have it so that as you consider in the future how you might use different possibilities of passkeys, you only get this data once, so you might as well go ahead and store it so that if you do want to use it in the future, you can. Really, all you need is the next part, the public key. Basically, the public key and the fields that you need in order to create the message that gets signed, that's all you need to worry about. The other stuff's just kind of fluff. But again, the public key, it's a function, not a property. You get it as an array buffer, so you're going to have to convert that to base64 to send to your server. And this is actually the format that is specified for this. So this is not an arbitrary format that I'm creating here. This is what is specified. What if you were to use a framework or a library, this is the format it would expect the data to be in. It doesn't have to be that way. You can do whatever you want. There's no, like I said, there's no security implication of the shape of this data. It's just the way that they decided to spec it, and it's not bad. Other than the fact that you can't call, you have to implement it yourself because the JSON method wasn't implemented. So you get the public key, and you get the algorithm type, and you'll have to map that on the server side from -7 to ECDSA P256. Then there is the authenticator attachment. This is a string. The string is going to be platform or cross-platform. We're going to talk about it. You can ignore it. It's useful for statistics. It's useful for auditing. But like I said, when you're looking at this as it's just a better password manager, so many of these features that they have that you can learn this or that, it's overkill. Don't worry about it. Then there's ID and the raw ID. These are actually the same in the JSON representation because the ID is the URL base64 and the raw ID would be the array buffer. But since we're calling the toJSON method, it gets converted to URL base64 as well. So there's no difference there. Then we have an attestation, which again, it's just information that's encoded in a binary format about iCloud or YubiKey or Brave or Chrome or whatever. It's data that I think you need part of it in order to verify the signature. I have to take a look at that function again later. There's the authenticator data, which, well, that seems kind of strange because there's the attestation data and now there's the authenticator data. Didn't I just say that the attestation data is about the authenticator? Yes, I did. There's just the attestation data is lower level data that you only get once. You only get it on the registration process. You don't get it in the future on future authentication processes. Whereas the authenticator data, you always get that during every interaction with a passkey. Then there's client data JSON. This is actually a string. And the reason it's a string is because it is used as part of the hash to verify the signature. And so it has to be an exact byte order. It can't have the keys resorted. So that's why it's a string. But it has information in it that you can look at if you want to. Then again, we already talked about the public key that goes in there. Transports. Again, this is something you'd only use for auditing or an enterprise scenario. I'm looking at this from a baseline. This is a better password. It's a more streamlined experience for a user. I'm not looking at it in terms of, okay, let's make sure that these users have a Bluetooth mechanism and these users have an NFC mechanism. I don't care. You know, if they used NFC on this or if they use Bluetooth on their phone, I don't care, right? But that information is available for you to inspect, for you to audit if you want to. And in the case of auditing or extremely sensitive processes, Bluetooth, for example, is an indicator that they're physically present because Bluetooth means that both their phone and their computer both agreed. So if you've ever tried to use passkeys and just send some of the QR code, it doesn't work because the QR code only works if the Bluetooth is in range of the device that's being authenticated as well. Again, progressive enhancement on the security. The more advanced these devices and services get over time, the better the security becomes automatically without you doing anything or worrying about it. And then the last thing is the type, which is WebAuthn.create, and then all of that data that's highlighted now is just metadata. So you don't really do anything with it. All right. So if you want to see what all of this looks like fully expanded, because there's a lot of data that I didn't show you, but we can take a look at it real quick, just to scare your pants off. If you were to decode everything that can be decoded, and there's 3 or 4 different formats that are used, ASN1, CBOR, a bespoke protocol that WebAuthn specifies for backwards compatibility with old FIDO devices and government installations and stuff. That small, relatively small amount of data that we looked at expands out to all of this. That's the JSON object decoded, the authenticator, the attestation, all of it. So
Are you saying Fido like as in a plant, like PHY?
no, FIDO, FIDO. So before it was called WebAuthn, it was called Fido, and back then it was really bad. And then it was called WebAuthn, and then we decided that basically most of WebAuthn is a no-fly zone, just kind of like OAuth 2. Like most of these options, please don't use them. And then Passkeys kind of emerged as the branded term for the baseline that works, that you don't have to worry about. All right, so from there, last thing that we need to do is back on the server, we're going to have our, I was going to put db.customer there, but db.customer.register and an email address that we still need to verify because you can't trust these credentials any more than you can trust a password. There's no central authority. It's just stuff that's generated randomly, either on their computer or by device or whatever. It doesn't speak to anything about their email or the phone number or any of that. It doesn't provide the assurances that OIDC does. It's just like a password. So we'd have whatever email address. We're still going to have to send them the email on the first account login to click that and verify their email or do the OIDC thing. Again, the purpose of the Passkeys is more about the convenience. It enables the one touch. It's not about roping in with other services or anything like that. Or if the user had already been authenticated, let's say they signed in and you just implemented Passkeys, you got a bunch of users, then you'd have some function you'd call to add the passkey. You look up the user by the verified email and you'd pass in the credential, which is that JSON object. And that JSON object that I described is one that you can always decode later, so I just store it in the database in encoded format, and I don't try to decode it or split it out into database fields. I grab it, I use the things I need to use from it in the follow-up process, and then I'm done. And then you'd have your, when you go to, what was I going to do with this? I don't remember why I showed this both ways, but yeah, so say you're posting to your API, you're going to validate. What I do is I call the object passkey. You could call it credential or something else, but that term's kind of overloaded with other things. So I call the object passkey, which is a perfectly fine thing to call it. And I validate it. I make sure that the public key exists and some other stuff before I store it in the database. Because we can't do the full loop right now because there's two halves of this. There's the public key that comes on registration, and then there's the assertion that comes every time you use it. But basically, if the data going in is bad, then when you go to do it, it's better to send back an error early. So like, the developer that was working on the front end, typoed the public key name. We don't want to, in some recent update, we don't want to store bad data to the database. So you just kind of want to, give it a quick Zod test or something to make sure that the object's in the shape that you kind of expect before you store it into the database. All right, so this is just an example. This is what one of my customer tables looks like. This is taken from an actual, well, in part, I changed it around a little bit. This is taken from an actual database that I have. And you'll notice that on this customer table, I don't have email or phone or password. That's because now that I have an authenticators table, which I'll show in just a minute, well, what did I say authenticators were? Phone number, SMS authentication, email, magic link verification, password verification. All of those things are authenticators. So I just put them in the authenticators table with the passkeys. And then, oh, look, now what can I do? If I have a policy that says you can't reuse the same password, I've got a stored copy of their old password that's just marked as revoked. Well, I'll show that in a second. But so, yeah, here's just standard stuff. Username, given name, family name, zone info, locale, created at, updated at, whatever. Nothing that
It
interesting.
seems like you're using the term ID to mean ID in this case, though, which is
Yes.
I messed me up.
Yeah, so this would actually be the customer ID. This is not referring to the arbitrary data that's stored on the device or service that isn't used for indexing. This is the normal use of ID.
There was another ID when you're creating the JSON object. Which ID was
That's
that?
the credential ID. Okay, let's go back to that because that's actually really important. Thank you for pointing that out. Yes.
Yeah.
So this ID right here is the credential ID. Both of these are exactly the same. So,
Useful ID.
yes, this
Okay.
is important. This is the credential ID. This is what we pass to exclude. So back, was that here? exclude credentials, the important one, that's what that refers to. And if you don't do it, but if your flow is correct, if you've designed your flow correctly, it won't really matter. But it's nice to have that safety there of knowing that you've got the IDs and you're excluding them. Now there is one security concern that I want to bring up about that before I move on to the next slide, which is there is some amount of data that can be characterized from the credential IDs. One is, does the user have passkeys, yes or no? Because basically we're saying, okay, I'm going to take the email address of the user, I'm going to go fetch their credential IDs. And the server, unauthenticated, hopefully rate limited or some hash cache barrier or CAPTCHA, whatever. But anybody can just query an email address and find out what comes back. Well, what does that let us know? Lets us know that it's highly likely that that email address has an account on the server. This is stuff that you already get anyway, just by probing your forgot password stuff, and so that's not really anything new. You get back a list of credential IDs. These are not PII. There's no security concern at that level. Where there is a security concern potentially is that credential IDs look slightly different based on whether it's Mac OS or Chrome or Windows, because the length is different and the characters being used may be different. So for example, one of them may use a character set that when it gets encoded to base 64 might only include, let's say, integers between 2 and 125. There could be some sort of underlying mechanism that for whatever reason the device or service chooses to use, that when we look at the data, we can determine, oh, this is shorter or this is longer, therefore it's likely this service or it's likely that device. And you can see that the difference between this and iCloud, they are different lengths in the credential ID. So you're letting a potential attacker know they have an account, a hint as to what devices or service they're using as passkeys, and then how many passkeys that they have, which that information won't necessarily be accurate because they can delete a passkey locally without you knowing remotely. Okay, so back onto this. This is what my authenticator table looks like. Actually, I call it authenticators. Did I do that there too? Yeah, because I was copying it. I actually call it customers and authenticators because it's a collection. But anyway, there I typoed it authenticator when I was copying it. So here's the interesting things. So I have value and details. The way that I'm using this is value is the thing that is semi-public. So for example, password does not go in the value field, but credential ID does go in the value field. The masked email goes into the value field. The masked phone number goes into the value field. And under details is where I put the non-public stuff. So the big whole registration blob for the passkey, I just put that in details. The actual password digest, that goes into details. The unmasked phone number, the unmasked email address, that goes into details. Actually, the way that I do it, I do have the email and phone masked as a different process. So I put the actual value for phone and just for ease of being able to query by them for other reasons. So I fibbed a little bit. I actually put the unmasked value for email and phone in value, and then I mask it in another step. But anyway, so yeah, there's that stuff. And then I have priority, like which is their primary email, what's their primary phone, whatever. I just have that there. So you don't have to do that. And then I have my customer ID to relate it back to my customer. So now what I've established though is a one-to-many relationship where one customer has many passkeys and other authentication methods, right? So now if a user wants to have 3 email addresses associated with their account, any 3 of these are allowed to log in, they can do that there. I also have the addresses table that has like their shipping address, their billing address, whatever, and then that email and phone there gets used for a different purpose. But if the purpose of the email or the phone is to be a mechanism by which they can authenticate, it goes in the authenticators table.
So how do they add new ones?
Add new what?
New passkeys. Like they have to start with 1, and then.
So for example, your operating system. So if they're using Safari, they're going to register an iCloud passkey. But if they're using Brave or Chrome, depending on the version and the day of the update, it may default to the Google Sync or the Brave Sync passkey. So they would have a passkey for the browser and the operating system. If they're going to be signing in on their phone, regardless of the browser, it's going to go through iCloud. So even if they have Brave or Chrome on their phone, it's going to be an iCloud passkey. So you'd actually be registering multiple passkeys based on the device. And the process for that is pretty streamlined because while you're acquiring these users, you just make when they sign in with their password, you make the button click that finishes the sign in with their password. You make that button click do the registration with the passkey. Then when they come back the next time, you have the autofill. So before they even get to the point of putting in their password, they're clicking in the username box and it has that drop down that shows that they can just sign in with a click. So that appears right here. Let me refresh again. Okay, so right here. So that box just shows up and then they click on it.
So if they signed in with, I don't know, with their iCloud one and tried to sign in on another laptop with their Google one, they'd just be like locked out?
No, it should just work because that's why we have the authenticators table. Because it's a one-to-many relationship. So
Like they don't have access to the iCloud one.
right, but they would still have their password.
Oh, okay.
Right. So this is a progressive enhancement. This isn't like a full stop. Like I don't see this as, okay, you've implemented passkeys, so you're going to just disable everybody's password. Anybody who's got a new computer, you can sign them up without a password, and if they've got the iCloud sync, then it's going to work just fine. And the flow that you would use would probably just be a magic link flow. Say that they have a new browser. They switch from Chrome to Brave. They go to sign in. Well, you fetch the credential IDs, so you know whether or not you should expect this. Now, you don't get to list the credentials. As the developer, you don't get access to the credentials, to the passkey manager, so you don't get to see what they have, but you do know from the server side whether to expect it or not, which gives you a hint. And then if the autofill doesn't complete, then you probably want to register a new one, and that you would use the credential ID to prevent you from getting in a state where you overwrite one that exists. So if you follow the flow that I've laid out there, you don't really have to worry too much about that. You just assign the button click that does the sign in. If they have a passkey, it just signs them in. Or they probably click the autofill, in which case you already got the autofill event. And if they get to the end of the process and they're signing with a password, then just register the passkey as well, because all they'll have to do is just touch the button and then the passkey will get registered from their perspective. You have another back and forth on your side, but it's nothing on their side. Okay, so now on to the other side of the process, which is the assertion. So we went through the registration process. The assertion process isn't much different, and we're not going to get through all of it, but the challenge is the same. There's no difference in the way you do the challenge. It's exactly the same. You're fetching, you're getting, whatever. You don't actually need to get the credential IDs for the assertion process. They're not used in the assertion request, but they can be useful to hint to you regardless. So basically, anytime you load the page, you're going to fetch a challenge and you're going to fetch credential IDs. You might not use the challenge, whatever. You might not use the credential IDs, whatever. But you could, if you had some specific information, like for example, let's say in the case of a cryptocurrency wallet, you would need them to sign in with their iCloud keychain, because whether they're on Chrome or on Brave or their other computer, you want to make sure that they are definitely, absolutely using the same key. So what you could do is you could allow only the key that has the private value associated with it. Again, this is beyond the happy path. I always get down in the rabbit holes, right? You don't need to worry about this. I'm just saying it's a use case that you could have it for, is you could use the credential IDs to restrict which IDs are allowed. So one is exclude on registration. You can say exclude error if it already has one. On assertion, you can say allow, only allow the ones we already have. I don't think that in general that's very useful. But anyway, so this object is much simpler. So here I've put in these constants because, again, this is one of those confusing, nuanced pieces. Conditional means autofill, and optional means button click. So the reason that they're named that way is because, again, the standard is broad. It doesn't just apply to web browsers. It applies to old devices. It applies to new devices. They've got a lot more that you can do with it in terms of WebAuthn than our limited scope of looking at it as Passkeys. So, and those two modes you're going to use differently. The button one you're going to use on button click. The other one you have an event handler rather than awaiting, because if you await it, then you won't be doing anything else because you'll just be there awaiting because you don't know if or when the user is going to click in the autofill. And if they were to put in their email address and click continue, you wouldn't be able to respond to it because you'd be sitting there awaiting the autofill that isn't going to happen. So yeah, so there you go. You put your autofill controller signal if you need to. And then for public key, again, this is a request. You're not specifying a public key. You're specifying what you want from the public key. And you want the public key to be signed with the challenge from the server. Here, it's RPID. You just want the domain. You don't need the name because you're not registering it. So providing the name wouldn't have any value. And then you've got your timeout and your user verification, which again, you just ignore because in these use cases, it's not used anyway. So with that, you go ahead and you, it's a button click, you await it. If it's not the button click, you assign the event handler. And then we're on to assertion step 2. The object that we got back, we have the same problem where if we were to console.log what we get back, it's an opaque object. So similar but different. We have a toJSON method that again is in the spec but wasn't implemented. You just have to read the documentation, but this is what you end up creating. The one thing that's different from the spec is that I put this function here, get user secret. The reason that it's there is so that it doesn't accidentally get console.logged, but you can still see that the function is there in console.log, so it's not completely opaque. And when you toJSON this to send it to the server, the secret won't get sent to the server. But this is the other weird thing, is that in this part of the process, it is called handle. Don't know why. It's just one of those nuanced things, right? So it's called handle. Why it's called handle, who knows? But they literally called it different things in different parts of the spec, and so it got called handle here. So yeah, but the important parts are the client data JSON, the signature. I can't remember if you end up needing something from the authenticator data. I think you maybe do. But the client data JSON and the signature, you don't really need to know what's inside them, except on the server side where you verify. And then we're going to move right along to, we talked about signature. So I will just show an example of what the verification looks like on the server side. But from here, and I put I put the globe here. This was locally. My bad, I was copied from the wrong thing. That was supposed to be the person icon. I'll fix that later. So from here, what you do, let's see, I'll just go look at the code real quick. So I have in here Go code. I find the Go code being the easiest to read, and then if you give the Go code to GPT, it can generate it in whatever your backend is. But I also have the JavaScript code. I will also publish the JavaScript code here. I just don't have it in here yet because, like I said, I'm working on 2 implementations of this before I consolidate it to just finally put it all together. But in passkey.go, we have, let me plus this a few times. Parse registration, no, that's not what we want. We want parse assertion. So there's a parse assertion. It parses the JSON. It creates, this is where the magic is right here. So this is what I would be putting in the slide if I had time for a couple more slides. This is it right here. So we would be taking the client data JSON and running a SHA-256 on it, and that would give us the client data hash. This is, they have a bespoke hash algorithm that they created for this process. Again, I don't know why. It's just one of those weird things. It's not difficult. It's not challenging. It's just tedious and unintuitive. But you create a client data hash from the client data JSON. That makes sense. The next part is what doesn't make sense, is that you're then going to take the hash that you just created and you're going to concatenate it with the authenticator data in the raw byte form. So you don't need to parse it. You don't need to know what's inside of it. You just need to concatenate these 2 things together. If you were going to create an authenticator, you would need to deal with that. But this is where I say, if you're following completely the happy path, you don't need a library. With what I've got in the slides and what I'm showing right here, you can do this. So you, there was one more thing I forgot to mention in that vein. But yeah. Then, so you append this together with the hash and then you SHA-sum it again. And I don't know why they do this because it seems like you could have just taken the data, put it together, and then done the SHA-sum on it, which would work better with the way that most cryptographic libraries work anyway, where you pass in the message data and then it does the SHA for you. Web crypto works this way, for example. Node crypto works this way. Most crypto libraries work that way. Go actually is a little lower level where you have to do the SHA yourself. So depending on what crypto library you're using, you're either going to pass in the verifiable hash or you're going to pass in the verifiable data. So one of these two representations of the data, depending on what cryptography library you're using. So again, there's not really anything here that you would get wrong other than if it doesn't verify, you know you did it wrong. But there's nothing really special about this. And that's that. So that's how you take the data that you get from the client, and then you are going to pull out the public key from the database. And the public key is already in a standard format. It's in it's in dir format, which is like PEM. It's a standard format. Like you just take it as bytes and put it into whatever crypto library that you have. Like convert it from base 64 to bytes, and then put it into the crypto library, and it'll work. You don't have to know anything about the key spec other than that it's ECDSA P256, which is what was in the slides. Anyway, so you do that, and then later you verify. Let me see if I actually have the verify function here, or I might have put it in the other place. Parse attestation. Do I have verify here? I think I actually put it in the other place. But just to show you an example of what it is, if I've got it in there. If not, I won't worry about it. It's standard, just .verify, and you pass in the signature and the key. Okay, so get previously stored challenge. You go fetch it in the database. And let me go down here. I'm parsing everything for funsies because I wanted to know what every property of this was so I could understand what was needed and what wasn't needed. Because when I look at the libraries and frameworks that exist for this stuff, super complicated. Super, super complicated. Thousands of lines of code. You really only need a couple dozen lines of code to get the process done. And a lot of the things that they're supporting are things that nobody uses anymore because they don't even sell the devices that they would be compatible with, or you don't need to worry about because it's a really enterprise/government use case that you don't need when you're just considering this to be kind of like a password. Okay, so here it is. So I take the ECDSA object, so the crypto object has an ECDSA object, it has a verify function, verify ASN1, and I pass in the key and the verifiable bytes, which is what I just showed a moment ago, and the signature. Now, there is one kicker to this, which is that the signature that they give you is in a different format than what almost every crypto library expects. So that is the one kicker, that's the one last thing, and I'm not going to show that code, but literally ChatGPT can do it. The format that it's in is called P1363, and the format that it needs to be in is called ASN1. And literally, if you ask ChatGPT in your language, write me a function that converts a P1363 signature to an ASN1 signature, it will get it right 100% of the time. Well, maybe 100%, I mean, there is a random component, but this is, it's just mixing the bytes. One is a 32 byte, two 32 byte strings, and the other one has a length in front of the byte string, and if the bit begins with a 1, then it has an extra 0 in front, and if it begins with a 0, it actually chops the extra 0 off unless the next bit begins with a 1, in which case it adds it back. So tedious, not something that's intuitive, it is standard, it's weird that they give you the signature in that format because it's not the one saying, oh, no, I lied, sorry. No, they give you the signature in the regular format. Forget that. That applies to web crypto. That only applies to web crypto. Their signature is not compatible with web crypto because web crypto is the one that needs it in the special P1363 format. So forget what I said. If you use a standard library with passkeys, it does work as expected. It's only if you're trying to verify it with web crypto, you got to worry about that. So that's that. Okay, so with all that, that's the nitty gritty. That's the details. I do want to continue to work on these slides a little bit more to try to get just a few things that we're missing. But that's the full process. Like, if this were a workshop and you were copying and pasting the code, We probably need to spend another half hour because of some other code that I didn't provide, like the base64 to URL base64. Again, ChatGPT will do that for you. Bytes to base64, ChatGPT will do that for you. A lot of the things they're tedious, but they're not anything that ChatGPT can't do.
You can use the Dino standard library for the bytes base64.
Yeah. In JavaScript, I just stick to JavaScript. I don't use Node or Dino for things like bytes and signatures.
It'll
but
work
yeah.
in the browser and all that, so it's not specific to Dino.
Oh, okay.
Yeah.
Okay, cool. Yeah, and then let's see. That's the end. So, questions, comments, feedback.
I was promised some assembly.
You want to do an assembly? ChatGPT can do that for you.
Can you repeat that? All of that?
Yeah, sure, no problem.
Okay.
It's recorded.
Oh,
Yeah.
You said forget that part at the very end, and I just forgot the whole thing.
Oh, whoops. Whoopsie.
And I wasn't sure what part to forget, so.
Whoopsie. All right. So this is the thing I honestly want to know. Does anybody feel like they, obviously not from memory, but with these slides as reference and the sample code, do you believe that you could or would implement Passkeys?
Yeah.
Yeah,
Could
try it.
Yes. Would. I think I'd have to. It'd have to become more of a default for people. Like if I try to do this on my machine, like it doesn't give me the option to set a pin right there. I have to open up Windows Hello and set it up first. Whereas the ideal of the web is that everything will just work all the time with no setup, right?
I did.
Setup are more universal.
I've tried it on a brand new Windows computer, and it seemed like it just worked. I don't think I had to set up anything special.
It works. It gives me the option to use a passkey. If I click that, then it says, would you like to connect an Android device or an iPhone or a security key or something?
Okay.
No options for Windows Hello. I can set up Windows Hello, but it's not set up by default.
Yeah, so I just used a standard installation of Windows, and so I just used like the default installation of Windows. So it had Windows Hello, like it forced Windows Hello. There wasn't even an option like with iCloud where I could turn it off. Like it was Windows Hello or bust.
Okay, I think it might be that I deliberately didn't connect my computer to the internet when I was setting it up and thereby bypassed a bunch of garbage.
Yes, so this is what I will say. There are people in this room and other rooms like this that will have a hard time with passkeys because reasons like that. One slide that I meant to put back up towards the beginning, which is a really important slide actually, is this one right here. This is how you determine if you should try passkeys at all. So global this or window.public key credential, on that you want to check, you have to await. And the reason you have to await is because if a device is plugged in, like a USB device, it's an asynchronous option to get it. So it's not just answering the question based on the browser and the operating system, it's also based on Bluetooth or USB or whatever else. But is user verifying platform authenticator available? What that means is there something where a user would click a button? Is something where a user would click a button there via Bluetooth, via USB, via whatever? And that will come back as true or false. And then you will check to see, is conditional mediation available? That means, is this platform, device, operating system, whatever, up to date enough that it can do autofill? And that will come back with true or false, or undefined, because we have to use the question mark here, because in the case, like let's say they're on Android that's a few years old, we need to have this because this function would not exist. So if this returns false,
Would the question mark dot exist?
yeah. If this, so I only do technologies when they're at least 18 months old. When I'm talking about implementing something for customers, I'm never going to suggest something that's less than 18 months old. Well, I won't say never. There might be really exceptional circumstances, but I'm not going to suggest something that you're likely to have problems with customers. And we as developers are not customers. You're going to have problems with developers because developers do things like turn off their internet when they're installing Windows, or to explicitly to get around all the prompts that force you to connect to the internet. Like no mom or person who's paying money for your product other than developers would have been able to figure out how to go through the steps to get Windows Hello disabled, right? But, so the point is...
I just ran into exactly that with my mom's computer because of how I set it up.
Right.
The
So...
way I solved it was by walking outside of my apartment sufficiently that it could no longer connect, and then with it set. Anyway, go on.
All right. Oh, interesting. Okay. Oh, that's good to know for the future, actually.
I
'Cause-
literally unplugged the router.
Oh, yeah.
Well, that won't always work though, because then it will be detected that it's not available, as opposed to if you walk far enough, then the internet's just bad. Anyway, so if this returns false, fall back to the normal process. Don't assign the passkey handler on the buttons. Don't present the passkey options. You won't be able to because the autofill won't be available anyway. But you will still be able to do the buttons. But if passkey support, if this returns false, don't do it. The device is several years old, or the operating system is several years old. It's an exceptional case. It's an unsupported device. Don't try. Don't try to figure out like, oh, if I conditionally check this and if I do this, because like JoJo has a key that will work with WebAuthn. It won't work with passkeys, as we've defined here. Baseline passkeys doesn't work with that. But it will work with WebAuthn. If you go through meticulously all of the different options and you tweak them to pass this here and that there, et cetera, it will work. Okay, hold on just a second. I am still presenting. Go that way. All right. So this is kind of that magic pill of if it returns false, just don't bother. Don't give yourself the headache. Don't give yourself the headache. Don't give your users the headache. And I'd be interested to see if you were to run this on yours, since Windows Hello is disabled, I'd be interested to know whether it returns true or not. Because I believe for the cases that JoJo and I identified with his devices, this will return false, which means that he would still be able to not have the deceptive presentation of options for things that we don't actually support. So the way that this is set up, it won't, resident key required, storing the credential ID on the device, having the ability to store arbitrary data. Those are all things that exist in iCloud. They exist in YubiKey for the past few years. But if you bought an authenticator device 10 years ago or 7 years ago or maybe even 5 years ago, those aren't going to be supported. And we don't want to give the person the false illusion that because it'll pop up with a prompt, it'll let you go through the process, and then it'll just fail. So we'd rather just not present them confusing options and not try to work through all the different variations of WebAuthn that have been implemented over the last 10 years. It was a bad time back then.
Go back 1 second.
Oh.
How you doing it?
It's passkeys.js.org,
Got it.
and it's slide number 45.
I got you.
Oh, whoops. Wait, passkeys.js. Oh, okay, something failed there. I gotta check that out. My CNAME file got overwritten because GitHub pages. Ugh.
Your what file?
It's passkeys.js.org, but when I most recently did a push, it deleted the file, the CNAME file, and so now it's reverted back to the GitHub pages because the way that GitHub pages work sometimes. So anyway. Oh no, wait, no, this is not that. No, this is still there. Okay, no, this is passkeys.js.org. If you go to passkeys.js.org, that's the demo. It links to the presentation. Sorry, I got my wires crossed there. The presentation is not hosted there. Just the link to this. Anyway, so then there was a bunch of other stuff that I'd gone through before These are all the documentation pages that I had to go through just for the registration object. And this doesn't have all of them. Because there's lots of hierarchy and it's kind of complicated and you have to figure out like, when do I use this option, when do I use the things that I presented to you are the options that just work. So you can go deep as you want. I just don't recommend doing it. Yeah, Act 2 is going to be the quagmire, but we've already dug into the quagmire enough. I don't think there was anything else in here that I really wanted to show. These are just the assortment of.
Unintentionally left me.
So my slide thing, the way that it works is that, let's do full, why is this not going out of full screen? Oh, because it's in full screen the other way. That's so weird, isn't it? So there's this full screen, it was in browser full screen, but then there's element full screen. So.
Okay, I can resolve that promise now. Is user verifying platform authenticator available? It's a gloriously great name for what that is. Gives me false.
Excellent. So what that means is Windows Hello is not set up on your device.
Good job.
So
Mission accomplished.
that was actually really, really great. Thank you for that.
Could have ruined the whole presentation.
No, I would have been really sad if it worked, because this is one of the things that people complain about is like, oh, there's so many edge cases, and my lie that I'm trying to tell you and sell you is that no, it can be done. Yeah, you need a library because you probably don't want to deal with all the tedium. I am going to provide the library. It will be available at passkeys.js.org. As you can see from the demo, I already have it. There's just some tweaks I want to make based on some of the things that I discovered. Like, for example, this little nugget is not in the library, but it should be, because this is important information. We should just bail if these two things aren't correct, because even if the device is capable of doing it, it means it's not set up to do it yet. So anyway.
It works good.
Is the code on the passkeys.js.org?
Yep, code is on the passkeys.js.org. Not all of the code
Git
there's the Git source there. And what I mean by not all of the code is that I have done some extra implementation that is in the product for PaperOS that, while it's not gone live yet. I kind of, before I publish the library as 1.0, I want to get the PaperOS implementation live, because then we know for sure. But I may publish it before then, because there may be some other things that hold that up, pipeline stuff with the product that aren't code related.
Mm-hmm.
So anyway, so I may publish the V1.0 before then, but if it's only going to be another week or two, I'll wait to publish the V1 of the library, so that way I have the experience of putting it in production and then it'll be done. Like we're not gonna have a V1.01, unless there's like a typo.
Yeah.
I'm not gonna be adding new features to it. It's gonna be completely unmaintained. Not that I'm not gonna maintain it, but that it will be done. Yes, I want to publish it and be done with it. I don't intend to be adding new features. I'm just going to say, you know what? There may come a day where there's something that I want extra out of Passkeys that comes about, because this standard is evolving. For example, there's things in the spec that are mentioned, but actually not there. They're just mentioned as, one day we might do X. One of those things is cross-origin. So one day there might be the ability to use a relying party that's cross-origin. Do I care about that? No. A lot of the things that are security related to this don't apply when you are using it as a password, or a replacement for a password. You're just looking at it in tandem of a more convenient higher entropy password. If you look at the spec or you listen to some of the security talks, you're going to say, oh, you need to verify the relying party, you need to verify this, you need to verify that. Problem with that is that would require that their operating system is malicious, or that their authenticator device is malicious, or that their browser is malicious. And if you're Edward Snowden, then yeah, you probably want a more highly specialized library. If you're the kind of person that would not log in with a password at all because you are fearful that the web browser has been hacked and is actively taking your keystrokes, you would definitely want to make sure you implement the hardware-only version of Passkeys. But for the rest of us, even the counter doesn't matter. because, again, they would have to have a malicious device. The purpose of the counter is that the device can't be cloned, but then what happens anyway? Everything gets virtualized. So I think iCloud has a counter, but the thing is, iCloud is just synced through iCloud. So it's a virtualized device, it's duplicated because it's on every one of your computers, and it just syncs the counter. So,
Password managers do that too. Like Bitwarden will do it. Like you can store the passkeys in Bitwarden.
Yeah.
Yeah.
Oh, that's the other thing is that you don't. All of this can be done in software. I actually, for the purposes of testing, I created an authenticator in JavaScript, and I was able to get ChatGPT to write me a CBOR library that worked. I was kind of surprised, but it wrote the CBOR library. CBOR is a format like JSON. It's just binary instead. So, but it's very well spec'd, and the nice thing about it is the only implementations that exist in general are high quality implementations. So the training data is perfect. The only problem is the context window. Like it'll leave out a function, then I'll have to say like, oh, you left out the object decode function. Like the very first time that I did it, it worked, except for I could tell just looking through it. It had like parse number, parse array, parse boolean, and I was like, oh, there's no parse object, and then it spat out the parse object function, copied and pasted it in. It worked on the first try. I was pretty happy about it. But anyway, yeah. So I've created a virtual passkey to be able to test things with each other, and yeah, a lot of this stuff you really don't need to worry about the security concerns that somebody might tell you need to worry about, because the same reason it's like you can't trust it in the first place. You can't trust it more than you would trust a password. It is a high entropy password, except it's public private key, so it's even more secure because you're only getting the public part, not the private part. But other than that, like the reason that most of the services don't support the attestation data is because, okay, somebody can just take this apart, they can desolder it, they can put it through an X-ray machine, and they can get out the key in here, and then they can take that key and they can apply it to something else. So if you see that you have an attestation that says this is attested as a YubiKey device, if you're worried about the Edward Snowden use case and your combatants are the NSA and other government level entities, no, because they can take the thing apart and get the certificate off of here and sign anything they want with it. So you have no proof. And I believe that that's why Apple doesn't even bother. Apple does not provide any attestation information because they know that people are just going to hack it and put Linux on it, and then you can read out of the ROM and you get the key, and then so you can't trust the authenticator in terms of if you're trying to think of all these scenarios. And another thing is that the authenticators were originally, the idea behind it was that they were going to be way more modular than they are. In practice, all the authenticators that exist on the market are produced by one of two companies, and they all have the security practices embedded in such a way that, again, if you can't trust the authenticator, you can't trust it in the first place because of first principles. But if you can trust the authenticator, it's made by one of two companies, so the authenticator isn't going to allow cross-origin requests. So you don't actually need to check cross-origin requests on your site because you're using a browser that implements the spec properly, and you can assume that you're using a device that implements the spec properly. And if the device doesn't implement the spec properly, then all of your guarantees go out the window anyway. So that, yeah, a lot of the stuff that somebody would say, oh, if you're doing passkeys, you got to make sure you do this. You got to make sure. No, would you do that with a password? You just ask yourself this: would I do those? Would those checks make any sense with a password? Because if the answer is no, then they also don't make any sense with a passkey, because the passkey is just a better password manager. It does not provide some sort of magical, trusted computing platform. But that's kind of what the spec wants it to be. But we haven't invented the chips that can be developed by Apple or Google, but then can't be understood by an electrical engineer or a governmental agency. So if one day we have magic chips that Apple can produce and the government can't read, then maybe one day all those other things could apply. But until then, the code, the browser, if you can't trust the browser, they're not going to be using one of these anyway. They're going to be using the browser. So if you can't trust the browser, you just can't trust it at all.
Okay. So your library, is it going to be a client component part of it and a server component of it?
It's going to be three components. It's going to be authenticator, the virtual device, the same thing that Bitwarden uses as the plugin. It's, well, not the same thing, but it's the same technology. Yeah, it's going to be, I've already got the Go side kind of sort of. I mean, it's not libraryized, but it's so small on the server side what you actually need to do. Once you know, if you cut out all of the seaboard parsing and all that, which you don't need for the happy path. It's interesting stuff to look at. It's interesting stuff to be able to know. It's interesting to be able to audit and say, yeah, we have a high degree of assurance that because we got this attestation data, likely their device isn't hacked. Likely they're not using hardware that was given to them by an NSA spy. That likely this is what happened. But yeah. So and then the JavaScript side, I'm actually going to simplify it a little bit from the way the implementation is. By simplify, I mean I want it to truly be like a library where there's the JSON function and you pass the object in and really nothing is done for you automatically. It's just the Legos. Like you're going to call navigator.credentials.get, but you're going to use my function to get the default object that has the values filled in and that will throw an error if you're missing values that you need. Like it's just going to be the tedium and the training wheels, and then maybe a little bit of correction. Like I might rename ID to secret so that it's not confusing. And there's one other thing like that I might rename and just make a note in the library. Like, I believe that you should learn the standard terminology. The problem with this terminology is it's antithetical to what it does, so we use non-standard terminology. But sometimes when people, when they abstract it away, it just makes it more confusing. Because, okay, you know the word authentication. Now I've introduced you to the word assertion. When you're talking about the passkey spec, assertion is authentication. If you don't know that, it's like, assertion. But if you know that, it's like, it's just authentication. So I don't want to abstract away from you the terminology, because then you get confused. It's like, it's a few more terms to learn. Most of the libraries, they abstract those terms away, but then most of them are also thousands of lines long. You can do this in a few dozen lines. Well, a few hundred, depending on whether you count the seaboard parser and some other stuff. But you don't need thousands of lines to do this. Anyway, oops, I ended the. All right, so anybody online, sorry, I was not fielding questions because I was presenting. But if you have any, throw them out now, and I'm going to cut this off in just a minute. So I hope that was worth the wait. If not, I'm not buying you a coffee. You just show it by not coming back. Show me that I did bad.